Hello everyone. This is another circuit synthesis example. In here, we have to construct the RL circuit, that means resistor and inductor circuit, for the following RC impedance function. For that one, we have to apply Foster forms. There are two Foster forms, first and second. The RC impedance function is given, ZRC is equal to S plus 1 over S times S plus 2. For the realization of this function, I already discussed in a previous video. The function is realizable. For that one, we have to check general properties of RLC network. For the RC function, we can write ZRC can be equal to the admittance function of a RL network. The RC impedance function is given, then we can find the admittance value of the RL network. It will be a YRL is equal to S plus 1 S times S plus 2. This is our function. In the first form, we can apply partial fraction expansion to this function. We can write the partial fraction expansion of this function. YRL is equal to A times S plus B over S plus 2. Now we have to find values of A and B, and it is equal to ZRC. I already discussed a partial fraction expansion of this impedance function. The value of A and B are equal. Value of A is equal to half and value of B is equal to half. Then I can write the partial fraction expansion 1 over 2 S plus 1 over 2 S plus 2. This is the partial fraction expansion of this admittance function. YRL. I will simplify the function 1 over 2S plus 1 over 2 times S plus 2. In here, elements are resistors and inductors. If I consider a resistor with the value of R, impedance value of the resistor is R and admittance value of the resistor is 1 over R. If we consider inductor with the value of L, impedance of the inductor is SL and admittance of the inductor is 1 over SL. We can use these terms to obtain what are the elements represented by each and every term. This will be a y1 and y2. First I consider y1. y1 is equal to 1 over 2s. When I consider admittance values, it is equal to this admittance value of an inductor. Then it will be an inductor. Value is 2. This will be L1, 2 Henry. Then I consider y2. It is equal to 1 over 2s plus 4. For that one, I consider impedance value Z2. It will be 2s plus 4. Then I had find what are the elements represented by each and every term 2s and 4. This I name as ZA and ZB. If I consider ZA, impedance value will be the inductor. L2 value is 2 Henry. And then I consider is a P. It is like a resistor R1 value is 4. These two elements are connected in series because of this plus mark. These are two are impedance value and connected in with plus mark. Then they are connected in series connection L2 and R1. And in the final circuit, these two admittance values are connected with the plus mark. That means they are connected in parallel connection. Then I can draw the final circuit diagram using first of all, first element is the inductor. L1 is 2 Henry. And next one, there are two elements, inductor and a resistor. L2 is also 2 Henry. And R1 is 4 ohm resistor. And we can obtain total admittance using these two ports, YRL. This in here, this will be the Y1 and this is the Y2. I hope you all are clear about first of all. Then I move to the second first of all. In second first of all, in the RC network, we apply second first of all for admittance function. For the ZRC, we are using first and YRC, we apply second first. If we consider admittance value of a RC network, it will be equal to impedance value of a RL network. Same as previous one, impedance value of a RC network is equal to admittance value of a RL network. Then admittance value of a RC network is equal to impedance value of a RL network. Then our admittance value is of a RL network is S plus 1 over 2 S times S plus 2. Then for the second first one, we have to consider the impedance value. We said RL S is equal to S times S plus 2 over S plus 1. Then we can apply the partial fraction expansion. For this one, we can't apply the conventional partial fraction expansion. Then I apply normal division. ZRL S is equal to S squared plus 2S over S plus 1. Then expansion will be S plus S over S plus 1. This is the expansion of this impedance function. And these are small impedance value Z1 and Z2. First I consider Z1 is equal to S. According to these terms, Z1 will be a inductor because there is S term, then this will be a inductor, value is 1. L1 is 1 Henry inductor. Then I consider Z2, it is equal to S over S plus 1, S over S plus 1. For that one, I consider the admittance value y2 s plus 1 over s is equal to 1 plus 1 over s. This will be ya and this part will be yb. If I consider ya according to these terms, it is a constant, that means it will be a resistor. This will be a resistor R1, value is 1 ohm. If I consider this one, according to that notation, it will be an inductor, value is 1, L2, 1 Henry. And these two are connected in parallel because of this plus mark, resistor and inductor connected in parallel connection, L2 and R1. But in the total system, these two are connected in series because of this plus mark. Then I can draw the final circuit. First element is an inductor. L1 is 1 Henry. And for the second part, there are two elements, inductor and resistor. For the inductor, L2 is 1 Henry and resistor R1 is equal to 1 ohm. And this will be the final circuit of the network. This will be the ZRL. Yes. This one is Z1 and this one is Z2. When we apply second first form for the given function, this will be the answer. That is the RL network that we can obtain. When we apply first form, this is the network what we can get after applying the first form. I hope you all are clear about this example, how to apply first form and second first form for a RL network. To construct a RL network, when we have RC impedance function, the example is given RC impedance function, then we have to convert into the RL function. The impedance of a RC network is equal to admittance of a RL network. Then we can do the process according to the process of first form and second first form. Thank you.